Okay, let's look at one other form that's sometimes valuable, and that's the point slope form. So if we know the slope m of a line and a point x1, y1 on the line, then we can use the equation y minus y1 equals m times x minus x1. So this is called the point slope form. Okay, so let's see, write the equation of the line that contains the point 1, negative 2. So we think of this as the x1, y1 pair. This is, of course, the slope. So to write the equation of the line, all we have to do is plug that information in. So here's our template. Okay, so y minus y1. So the y1 is negative 2. The m is negative 3. X minus x1, that's 1. So negative and negative is positive. Start inside the parentheses. Then let me distribute. Subtract the 2, and then I have it. Okay, so there's my line written out, written nicely in our favorite form, slope-intercept form. So if I wanted to, I could do quick graph. Now that we know slope-intercept form, graphing's pretty easy. So the y-intercept is 0, 1. The slope is negative 3 over 1. So down 3, right 1. Or up 3, left 1. Quick sketch of our line. Here's a special one. So as soon as I see slope of 0, I'm like, okay, this is going to be special. Let's see if we can use our same template. Y minus y1 is m times x minus x1. Remember this one, that's the point slope form. Okay, this is our x1, y1. Okay, so y minus y1, this is our m. So y plus 3 is 0 times x minus 2. Now 0 times x minus 2 is just 0. So look, remember I was saying this is a special line. As soon as I know the slope is 0, I know I'm dealing with a horizontal line. So there's my horizontal line, y equals negative 3. You can see the slope is 0, it's flat, and it goes through the point, indeed, to negative 3. Well, this is another special one. As soon as I know I'm dealing with a vertical line, I know vertical lines are always of the form x equals number. So I should really be able to do this one without doing really any work. Do a quick sketch. Let's see. Here's the point. I know the line is vertical. It's going to look like so. So what is the x going to be equal to? The x is going to be equal to 2, right? Well, here's another special one. This is almost like number 2. If I know I'm dealing with a horizontal line, I know the slope is 0. I know horizontal lines are y equals a number. What number is the y? It's -4. I mean, I'm done. Okay, if you want to graph it, if that's part of the instructions, well, the point is here. I know the line is horizontal. It's going to be here. So indeed, y equals -4. So what if we're given 2 points? So in order to use either of the equations, I mean, let's stick with this one. So we're going to use the point slope form. I have to be able to fill in these pieces of information, right? This is the y, let's do it this way. This is the y1. This is the m. This is the x1. So I need this, this, and this, these 3 things, right? Well, I actually have 2 points. So I could use either of these. Like I could use this as the x1, y1, or this. It doesn't matter. So I've got this and this, but what I'm missing is the m. So the first thing I have to do is get the slope. So remember, the slope is the rise over the run. So that's the change in y, right? And the run is the change in x. So if I'm given 2 points, so I have an x1, y1, let's call this one then an x2, y2. So wouldn't I get the change in y by just subtracting? So y2 minus y1, and the change in x by subtracting the x's? That give me the difference in x, right? So to get the slope, if I have 2 points on the line, I just use that equation. y2 minus y1 over x2 minus x1. So look back up here. y2 minus y1. So 8 minus 4 over x2 minus x1. 0 minus 2. 8 minus 4 is 4 over -2 is -2. So now I found the slope. I'm going to need more room. So now I'm going back up and I'm going to fill this in. It's not what I want. Okay, so let me see. Here's my x1, y1. Here's my slope. So let's see, the y1 goes here, that's 4. The m is -2, x1 is 2. Now I distribute the -2 and then add the 4. so there I have my line in the slope-intercept form. And so I could do a graph squeeze it in here. Let's see. The y-intercept is 8. The slope is -2/1. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And then let me see if our line goes through the 2 points. Let's see, the 2 points given. Let's see, we had the 2, 4. 2, 4, oh, there's that one. Oh, and here's 0, 8. So it looks like we did everything correctly. Just taking a look. These are all very similar. I don't know if we need to do all of these. Maybe, let's see what they are. So, starting out the same way, this is my template. That's my point slope form. So remember, I've got to fill in y1, m, and x1. So I can pick either of these. Like maybe I'll pick this one this time. Doesn't matter which one I pick. So if I use that one, then let me see, I'll have y minus, y1 is 3. I need the m still, I don't know that. X1 would be -1, double negative. So I still have to get the m, which is the slope. So if I have 2 points on the line, I'm going to be using this equation, the difference in the y's over the difference in the x's. So with the way I did the labeling up here, then this guy would be x2, y2. Okay, doesn't matter as long as you keep like 1's together and 2's together. So let's see what I would have. I'd have y2 is 18 minus 3. X's, x2 minus x1. So make sure you do those in order. So 4 minus -1. 15 over 5 is 3. So now I know the slope that goes here. Then I can finish the calculation. That part's pretty easy, so let's see, distribute. Well, that's a positive. Add 3. Okay, shall we do a quick graph? The y-intercept is 0, 6. The slope is 3 over 1. So up 3, right 1, down 3, left 1, etc. And then should I check? Well, let's see, -1, 3 is on there. The other point was 4, 18, so that's going to be way up here somewhere, right? So I guess the other way I could check that would be I could think about, well, if I was to take my line here and I was to plug in 4, would I get 18? 12 plus 6 is 18. So yes, looks like that's correct. So if it doesn't fit on there, that's okay. That's fine. Okay. I guess these are kind of special ones. That's why there's so many that are similar. So I'm kind of just thinking, how do I know this one's special? Because I notice that the two y coordinates are the same. So the points given, let's see, we have -1, 1 and 2, 1. So I can tell you immediately the answer to this problem. This is a horizontal line. Remember, the equation of a horizontal line is y equals number. So what is the number? The number is 1. I'm done. I mean, if you really wanted to use the point slope form, you could, but it's not necessary for a special case, because if I went to find the slope, I'd do y2 minus y1 over x2 minus x1. So let's see. It'd be 1 minus 1 over 2 minus -1. It'd be 0. But I already knew that because I know a horizontal line has a slope of 0. Let's plug in the values for the x1, y1. 1, -1. So look what happens. This whole side zeroes out. Don't you just add the 1? So you see, I really didn't need to do the point slope form because I actually know I have a special case there. So it's not necessary unless you want to. Okay, if you already know you have a horizontal or a vertical line, you can just go ahead and write the equation. I don't know why I have this one. Let's see. Oh well. This one's another special one. I could tell you immediately because you see how I noticed these two coordinates are the same? The x coordinates. Okay, so let's see. 2, -1. And 2, -4. So you see, that's the other special case. That's a vertical line. I know vertical lines are always of the form x equals number, so x equals 2. So actually for this one, I can't even use the point slope form because the slope for a vertical line is undefined. So actually for this one, I have to rely on the fact that I know the equation of a vertical line just by looking at the information given. All right, I guess we can do this last one. I mean, I think that's really similar to the others, but I guess it's good practice. Let me start by finding the slope. I know I'll need that. So negative 19 minus negative 9 over 8 minus 4. Negative 19 plus 9 over 4. Negative 10 over 4. Negative 5 over 2. Okay. Then I'll go with my point slope form. I have to fill in the y1, the m, and the x1, right? Okay, so just my pair. The y1 was negative 9, m was negative 5 halves, x1 was 4. Do the algebra. Distribute. So I'll have to multiply those fractions. I guess that's why this one's in here. It's a little bit more algebra to it. Negative and negative is positive. Let me see. 5 halves times 4 over 1. Five times 2, 10. Subtract the 9. Y equals negative 5 halves x plus 1. And there we have it. I guess we can graph one more. Why not? The y-intercept, the slope. Okay, here's the y-intercept. Slope says go down 5, right 2. So again, with negative 5 over 2, I could also think of that as 5 over negative 2. That'd be up 5, left 2. 1, 2, 3, 4, 5, left 2. Okay, and then let's fill that in. See what I was given. I think the points I was given are pretty big. 4, negative 9, 8, negative 19. So I think we won't worry about checking this time. Looks good.